Hello, thank you. Let me just share the slides. Can you please confirm you can see the slides?
Yes, we can see them in full screen. Perfect. Please go ahead.
Okay, thank you. So my name is Filippo Cugini from CNIT, and I'm the project coordinator of the CESON project. CESON stands for Self-Managed Sustainable High-Capacity Optical Networks. It's, as anticipated, of course, is a Stream A project, a research and innovation action, and this is the consortium. So we have two operators that are key in the development of optical network-based solutions that are Telefonica and Telecom Italia. Then we have ADVA, Infinera, and Ericsson as system vendor and system integrators. We have CNIT, CTTC, Fraunhofer, and Universitat Politecnica de Catalunya as academic and research organization. And then we have finally SMEs, innovative SMEs such as Acceleran, Wings, and West Aquila. The overall goal of the CESON project, as I mentioned, the key focus is on optical networking. So the goal will be to design and validate a transport network infrastructure that will be able to support the beyond 5G scenario and emerging services. So the network scope ranges from the wired access part connected to the metro part and up to the core. So it's an end-to-end approach that ranges from that ranges from the cloud up to the access part, and the goal is to improve and go beyond in terms of capacity and energy efficiency. To achieve this goal, we leverage on three main pillars. The first one is related to a novel data plane technology that is able to scale better, leveraging on technologies like multi-band optical networks and space division multiplexing. We will also try to fill the gap between the optical layer, the packet layer, and also the computing layer. And finally, we will leverage on AI and on mechanism to provide self-management and autonomous networking. In terms of data plane technologies, the goal is to move from a current optical network, which is typically based on the use of a single band, just the C band typically, to the use of multiple bands, and also to consider scenarios in which multiple fibers or new fibers provided with multiple cores are available. So the goal is to enable two order of magnitudes more in terms of capacity. Why this is needed? This is needed because in some scenarios, fibers are very scarce resources, so it is necessary to exploit other band to cope with the need for additional capacity. In other cases, fibers are present. So in that case, is not the best efficient solution to investigate other bands where the costs might be higher for a single component, but in that case we may stay in the C band but use multiple fibers. In other cases, new fibers need to be deployed, for example, towards the cells, to the antennas. In that case, we will also investigate the use of new types of fibers that are equipped with the cores. So as you can see, a sustainable way to increase the capacity is to leverage on all these scenarios. And in order to combine efficiently all these solutions, we need to have scalable and granular switches that are able to mix together and to provide an effective solution to exploit all these technologies altogether. So we are going to develop a new optical switch that will be modular and multi-granular to cope with these levels of dimensions. And also we are going to investigate new transmission capacity. We need to increase the capacity per channel, and we are going to investigate both point-to-point and point-to-multipoint solution. and also to improve the aspects for the optical transmission systems, in particular considering improvements in terms of energy efficiency and monitoring aspect of the coherent transmission systems. Here there is an example of where we could apply these multi-core and multi-fiber and multi-band scenarios is to serve microcells and 5G cells with an optical infrastructure that can be coordinated at the optical layer together with the wireless layer. For example, to provide coordinated cell activation, deactivation, and to move efficiently the traffic and enabling, say, sleep operation and moving traffic to save energies. In order to be efficient, we also need to provide new monitoring scheme, basically a pervasive monitoring infrastructure that will leverage on also technologies that are embedded in the data plane in the hardware. For example, the DSP, the receiver, providing the digital signal processing for receiving the signal, can be also used as a monitoring to improve the monitoring of the infrastructure as well. So all these technologies operate at the data plane level. And of course, they need to be combined with the technologies that stands a little bit above in terms of layers, that are the packet layer and the computing layer. Here is in the top corner is a typical example of edge computing scenario with which crosses a packet node for aggregation with the terminations, many terminations here in terms of OEO, opto-electro-optical conversions. We would like to investigate a single element that will be a computing node, such as the novel data processing units, or sometimes called smart NICs, standalone elements, that will be equipped with optical coherent transmitters. So the idea here is that we have the potential to significantly reduce the number of OEO conversion, the latency, but of course there are many challenges that need to be solved. And one example, besides the computing part for low latency application, will be also the support of the in the context of the 5G infrastructure to support decentralization in the implementation. So basically moving functions close to the cell site. So moving from a traditional deployment in which the national central office, the regional central office, the local central office, and the mobile sites are all involved, and where OEO regenerations and conversions are implemented everywhere, to a scenario in which the fiber optics is exploited from the core to even to the mobile site. So with clear benefits in terms of latency, because the applications are closer to the user, in terms of energy efficiency, since all these regenerations are avoided, and also some simplification, for example, eliminating some tunneling or some, say, enabling some bypass. Of course, all these data plane technologies at both the optical layer and the integration with the packet and computing layer need to be served by a proper control plane infrastructure. So in this case, we need new solutions in order to control the novel technologies, such as the multiband over space division multiplexing transmission hardware. We also need to better integrate, to efficiently integrate the control of the RAN with the control of the SDN, the access and metro part. And also, we would like to introduce novel concept for what concerns the optical scenario that are based on the net DevOps approach. Of course, everything will be driven by AI in support of network operation. And to this extent, we will, say, import the concept of multi-agent system also in the optical domain, also providing an optical layer digital twin to have clear, say, view and understanding of the analog performance in the optical layer. And of course, these must be supported by a proper telemetry stream, telemetry system that will be augmented with some intelligent data aggregation. The project will validate the decision project will validate the solutions in two demos. One will provide the operator perspective. So the main testbed here will be in Berlin, provided by Fraunhofer. As you can see, it ranges from the access part, microcells, small cells, traverses an access infrastructure, a metro infrastructure, and includes also cloud resources. And this testbed will be augmented with emulation, with emulated devices in such a way that we can really demonstrate, for example, scalability and also the efficiency of the solution in terms of capacity and energy efficiency from, let's say, the end-to-end perspective, from the operator perspective. The second demo will be from the user perspective. So this demo will be done in the let me say, beautiful city of L'Aquila, which has been renewed after the terrible earthquake, and it will be a sort of open virtual museum in which users will be able to experience profiled real-time content, but providing real-time content that is profiled to the user, meaning that under the same area, multiple content will have to be provided, personalized. So we need the high bandwidth, and we also need the high capacity. And the city of L'Aquila is served by a novel infrastructure supporting multi-core optical fibers, new generation of optical fiber. And we will also experiment their ORAN and SDM and an integrated scenario that will range from computing to wired to wireless infrastructure. So this concludes my brief overview of the season project. If you have questions, please contact us through to this link. Here is our website, which also includes the link to subscribe to our social networks. Thanks a lot.